Hello my dear children, welcome back to our maths class. Today we are going to discuss a new topic that is factor theorem. Factor theorem. Okay. In your textbook there is another theorem that is remainder theorem. Okay. A remainder theorem is a deleted portion and we will not take it. Okay. So let us learn factor theorem. Okay. Factor theorem means I will read. Okay. If p of x is a polynomial of degree n greater than 1 and a is any real number, then there are two statements. Okay. First one, x minus a is a factor of p of x if p of s equal to 0. Then second one, p of s equal to 0 if x minus a is a factor of p of x. Okay. See, let us discuss in detail. If p of x is a polynomial of degree n greater than or equal to 1. Okay. Factor theorem is applicable for polynomials having degree greater than 1 or equal to 1. Clear? Listen here. 5. 5. 5 is also a polynomial. Isn't it? 5 is also a polynomial. 5 is a polynomial. Okay, what is the degree of this 5? This polynomial? Actually 5 is 5 into x raised to 0. X raised to 0 is 1. Clear? So degree of this polynomial is 0. Degree of this variable is 0 now. So degree of this polynomial is 0. Okay. For factor theorem, degree of polynomial should be equal to 1 or greater than 1. Here degree is less than 1, so we cannot apply factor theorem for this type of polynomials. Okay, so that is the meaning of n greater than or equal to 1. Okay, we are applying factor theorem only for polynomials having degree n greater than or equal to 1. Clear? And a is any real number. A is any real number. Then x minus a is a factor of p of x if p of a is equal to 0. If p of a is equal to 0, then x minus a is a factor of p of x. Clear? Second, just opposite. Okay. P of a is equal to 0 if x minus a is a factor of p of x. Clear? Let's discuss this statement, this factor theorem by using one example so you can quickly understand. Okay. For example, instead of x minus a, we are taking x minus 1. Okay. X minus 1 is a factor of p of x. P of x, our polynomial is suppose x square plus x minus 2. Okay. So this is also a polynomial. X minus 1 is also polynomial, linear polynomial. Clear? Then p of x is x square plus x minus 2. Okay. If p of, what is the statement? X minus is a factor of p of x. X minus 1 is a factor of x square plus x minus 2 if p of a is equal to 0. If p of a, that is p of 1. P of 1 is equal to 0. Okay? If p of 1 is equal to 0, then only x minus 1 is a factor of this polynomial. Let us check. Okay. Then what is the relation x minus 1 and 1? What is the relation? How we will get p of 1 from this x minus 1? Okay. X minus 1 also a polynomial, linear polynomial. Then how to find 0 of this polynomial? Just convert this polynomial into polynomial equation. We already learned it. Okay. So x minus 1 equal to 0, then x equal to 1. Okay. Then p of 1. That is p of 1. Clear? So let's check this whether p of 1 is equal to 0 or not equal to 0. Okay. P of 1 is equal to what? 1 square plus 1 minus 2, that is 1, 2. 1 square, 1 plus 1 minus 2, that is 0. So here p of 1 is equal to 0. So we can, here P of 1 is equal to 0. So we can say that x minus 1 is a factor of this polynomial. Clear? Here P of 1 is equal to 0. So x minus 1 is a factor of P of x. P of x means x square plus x minus 2. See, this is factor theorem. Clear? The second statement also, we can explain second statement also by using this example. See, P of 1 is equal to 0 if x minus 1 is a factor of P of x. This is opposite of this statement. Okay, so factor theorem says that if P of x is a polynomial of degree n greater than or equal to 1 and a is any real number, here a is 1. 1 is a real number. Okay, we can take any real number as a. Then x minus a is a factor of P of x if P of a is equal to 0. Okay, that is x minus 1 is a factor of P of x, then P of 1 is equal to 0. Clear? So let's discuss some problems. Okay, dear children, let's start with our first problem. If x minus 1 is a factor of P of x is equal to x square plus x plus k, then find the value of k. Okay, it is given that x minus 1 is a factor of P of x square plus x plus k. Okay, this question is related with the factor theorem. X minus a is a factor of P of x. Okay, so we know according to factor theorem, x minus a is a factor of P of x if P of 1 is equal to 0. P of 1 is equal to 0. Clear? So let us start to write an answer by factor theorem. What is factor theorem? X minus a, or here x minus 1 is a factor of P of x, that is x square plus x plus k. P of x if P of 1. How P of 1? Yes, x minus 1 is a polynomial, linear polynomial, and equate this polynomial equation to 0. Take the polynomial equation, that is x minus 1 is equal to 0, then x is equal to 1. That is P of 1. Okay. So, equal to 0. This is factor theorem. Let's check P of 1 is equal to 0 or not. Okay. So, P of x is equal to what? Given that P of x is equal to x square plus x plus k. Then P of 1 is equal to x square, that is 1 square plus 1 plus k. Okay. It is given that x minus 1 is a factor of P of x. So, this P of 1 should be equal to 0. Okay, already given that x minus 1 is a factor of P of x. So, according to factor theorem, we can say that P of 1 should be equal to 0, which implies 1 square plus 1, 2. 2 plus k is equal to 0, which implies k is equal to, take this 2 into RHS, minus 2. So, value of k is minus 2. Clear? So, for this type of questions, it is already given that x minus 1 is a factor of P of x. So, if x minus 1 is a factor of P of x, P of 1 should be equal to 0. So, P of 1 should be equal to 0. Equate P of 1 to 0. That is 1 square plus 1 plus k equal to 0. Then 2 plus k is equal to 0. Then k is equal to minus 2. So, value of k is minus 2. Clear?